Hello everyone, this is a video lecture for Calculus 3, section 15.6, triple integrals. Honestly here, there's nothing new to talk about. We've already been doing double integrals, here we're going to do triple integrals. I'm going to do a couple. The section isn't too long, but I didn't really have very many to go over with you, because honestly they're all about the same. You just do one more. So I got integral from 0 to 1, y to 2y, and then 0 to x plus y of 12xy dz dx dy. Now watch out. Normally we do dz dy dx, but here they switched it up. Okay, so this is normal, but they switched it up. So just watch out because they're going to do that sort of thing to you. It's just random, I guess. Whatever. So, just like double integrals, triple integrals are going to work from the inside and then out as you go. So really, honestly, we should just stop the lecture here. There's not anything else new. But we'll do a couple, just kind of, get used to it, and then that's it, okay? So, integral in terms of z, there isn't a z. So, I just add a z in there. 0 to x plus y dx dy. Go ahead and toss this into z. Nothing new there. 12xy times x plus y dx dy. Alright, to make a good integral, I think I'm going to distribute this guy right here. So 0 to 1, y to 2y of 12x squared y plus 12xy squared. Again, dx dy. So notice that the x's are coming next. Integrate your x's. So then we have 12x cubed y over 3 plus 12x squared y squared all over 2 from y to 2y dy. You can simplify that just a tiny bit, make it look a little bit more presentable. 4x cubed y plus 6x squared y squared dy, again from y to 2y. Plugging in my y's there into the x. And so you'll get a big ol' mess. Let's see here. I'm just gonna go another line here because this is gonna be really big. So what you would get is 4. I'm going to go ahead and try to automatically do some of this math here if that's okay. So when I cube it, it's going to be 8 y cubed times another y there. 6 4y squared times y squared. And then for the minus sign, so all this now minus the y. Tossing in y, I basically get 4y to the 4th minus 6y to the 4th here as well. If you're kind of zooming out, you get y to the 4th, y to the 4th, y to the 4th, y to the 4th. They're all y to the 4th. So you got essentially y to the 4th times, and what are your numbers in the front? 32 plus 24 minus the 4 minus the 6. That's just a constant. You can toss that out to the front if you like. Makes a 46. And of course we know this integral here, y to the 5th over 5, from 0 to 1. 0 is going to cancel, the 1 tosses in there. Oh, so then 46 over 5, and you're done. There you go. Next one, 15.6007. So I got integral 0 to pi, integral 0 to 2, integral 0 to the square root of 4 minus z squared of z sine of x dy dz dx. Make sure you're watching out for this, for the order that you're going to be doing this. So notice that you're going to take an integral in terms of y. There's not a y there, so you toss the y down, and then you go and plug it in. The 0 is going to cancel. Blah, blah, blah. Basically, you're going to get z and then the square root of 4 minus z squared. Still have a sine x, dz dx. U substitution, done that quite a bit here in the past couple of videos. And so essentially what you're going to get here is a negative 1/2 that's going to come to the front. 0 to pi still of, I guess you can say, integral u to the 1/2. Remember that sign x, du dx. Add 1 to the power, divide by the power, divide by the new power. So when I integrate this, it's 2/3 now. U, already know what u is. It's 4 minus z squared. To the 3/2 from, and now back to z's again, we had 0 to 2. dy. Was it? Oh, it's dx. I'm sorry. Notice one thing I messed up here. Did you see it? Where did the sign x go? I messed that up so many times. When I'm going through, I forgot about the sign x. Oh man, and I kept going, and I missed it again. So just watch out for that sort of stuff, okay? Plugging in the 2 makes it go to 0, but plugging in the 0 makes it actually a number. And so you'll get that 4 there. So here we go. And notice that whenever you're plugging into 2, you will get a number, normally. But here it's 0. Minus, whenever you plug in the 0, so 2 negatives here are going to eventually make a positive. 2/3. And then here again, when you plug in that, you get 4 to the 3/2. Square root of 4 is 2. 2 cubed is an 8. There we go. There I go again. Sine x dx. Watch out. You got that sine x still there. These 2's are going to cancel, so you got 8/3 in the front. Again, now it's positive. When you integrate your sine, it'll make a negative cosine from 0 to pi. Yep. When you plug in the pi, you get a negative 1. And when you plug in the 0, you get a positive 1. So this is kind of strange because you get negative of a negative 1. Actually, you know what? I'm going to pull this minus sign out to the front so I'm not confused, if that's okay. So I'm going to make that a negative. I'm going to do this first. And then I got, okay, plugging in just the cosine now, a negative 1 minus, and then I plug in the 0, I get a 1. Notice that it's going to be a negative 2. 2 negatives make a positive there, so basically 16 over 3 positive. Another one, 15,6018. So triple integral over e, not really sure what that is, x minus y dv. So dv is essentially for my triple integrals, just like dA is for double integrals. They want to know what that is. They say that we have surfaces of z equals x squared minus 1, z equals 1 minus x squared, y equals 0, and y equals 4. Now this is kind of strange. I'm also going to go ahead and take these and say, oh, they're equal to one another, and start to solve. So I'm going to move this over, move that there. Actually, right. Okay, hold on. This is let me not do this way. This is still good. We want to do this. I'm sorry. I looked at my notes and I said, oh, just go ahead and pull it. Before we go and do that, I want to do that here in a minute, but I want to first draw what this is supposed to look like. Okay, so here's the thing. What we actually have are these two surfaces. This is an upside down. No, this is the upside down parabola, and this is the right side up parabola, but it's at -1. So, and these parabolas are literally on this plane right here, okay? Just for a minute. They're going to extend out, but I'm just thinking, look, z's and x's. That's it, z's and x's. And there's the other ones right here. Notice that they're colliding right here at, essentially it's going to be 1 if you do the math here. Set this equal to 0. And so we got 1 minus x squared equals 0. X squared equals 1. X equals plus or minus 1. So -1 and 1 for my x's. Well, this actually is like tubes. They extend out all the way from 0, where we are at right now, to 4. So basically, here's another set of them. Okay, now that kind of looks weird, but from my xy plane, and this is z, essentially we got these two little parabolas here. It doesn't quite make like a circle. It doesn't look like a circle. It kind of looks more like a football, I guess. And so we have this kind of football area here, but it's more of a tube. So it's running as a tube for about 4 there. What I did is I understood this as a shadow here, extending out this way. Notice that I'm going from -1 to 1, and I'm going out here from 0 to 4 for y. So this shadow on the xy plane is actually going this way here. -1, 1, going out to 4. Okay, so that's its shadow, looking straight down on the z-axis. Okay, so what I want to do is actually get my triple integral here to work to find whatever they're wanting. It's not a volume. I know it says dv, but that's just the way it's, yes, d volume, of course, but we have this density. So a variable density means that we're not just looking for volume, we're looking for like a mass or something like that. Regardless, so triple integral, and then of course we got our x minus y, and I'm going to go dz, dy, dx. Well, the z's are kind of not too bad because we're given 2 z values. What's on top and what's on bottom? Top and bottom. The top one is actually the upside down one. So this goes up top, this one goes on the bottom. Okay. For my y's, they already said it, 0 to 4. So that's not too bad, 0 to 4. And then my x's, we already discovered that as well, -1 to 1. Now you can set this up in a different way, but I like dz, dy, dx personally. So then we got to start doing this integral here and figure out what to do. So is there a z? No. So you add a z, you toss it down, and you get those two functions multiplied by this. So top and then minus the bottom, dy dx. Okay, here's the thing. I messed up right here where I was combining them. Now notice, distribute your negative. You got those 2 negatives there, and you got these now 2 negatives make a positive, combine with a 1 to make a 2. And so what you have is 2 minus 2x squared. What I had done is I messed up here. I didn't put a 2 next to that x. So watch out. There are 2x squares there. I recommend foiling. So go ahead and foil this thing out. I know it's not, the best looking thing to do, but I think it's the most effective. So 2x minus 2x cubed minus 2y, and then plus 2x squared y. We haven't done an integral yet. Dy dx. And they're all different terms, so there's not any combining like terms there. Actually, let's do our integral. So doing the integral in terms of y, 2xy minus 2x cubed y minus, and that'll be a y squared in the end, and here the 2's going to cancel again, x squared y squared from 0 to 4. The 0 will cancel stuff, so you can toss in the 4 to all those. Oops. So then we got 8x minus 8x cubed. Here is minus 16. And then here we got 16, positive 16x squared. Just check my notes to see if we're in the same place. Yep. All right. Simply put, you can definitely put that, you can do your integral again for x's, add 1 to the power, divide by the new power. I cheated and used the calculator. But, I mean, that's a small cheat in comparison. I got a negative 64 over 3. And notice that it's negative. Again, we weren't looking for volume. It's kind of like a mass, but again, we could have a negative density. It's kind of strange. I don't know. Just doing what they're telling me to do. 156064. I believe that this is the last problem that we're going to do here. This one's a center of mass kind of thing, but I need to show you quickly what's going on with this here. We got planes, x equals 0, y equals 0, z equals 0, so that's basically octant 1. X plus y plus z equals 2, and then I have a density of 7y, so that's rho equals 7y. They want little m, and then they're going to want my x bar, y bar as well. Okay. Pretty sure. Actually, looking ahead, and of course you would see this on WebAssign. They want X bar, Y bar, Z bar. Okay, so that's definitely a little better there. Okay, so first off, let's find little m, and then we can use it for the rest of the stuff. To find out what's going on, I really want to graph it. So looking here, we got X, Y, Z. 0, 0, 0 says that it's going to be in the octant, the first octant. This plane right here, you could just move these guys over if you want to, but essentially you just got some kind of plane, kind of like we've seen earlier. I think this is a 2, and I think the others are going to be 2s as well, like 2, 2, and 2 essentially. And so it just has some kind of triangle plane right now. Now, just as a reminder, planes extend out forever. This thing is actually going out forever in all these different directions. It's like a sheet of paper, but unlimited, an unlimited sheet of paper. What I'm focused on is in quadrant 1, so I don't really care about the rest. I'm just looking at this plane right here. And they're wanting to know the center of mass for this guy here. I think it might be the whole shape, actually, if I'm thinking. It might be the tetrahedron or something. Anyways, when you read the problem, it'll tell you a little bit more. But yeah, bounded by these planes here, I think it's the whole entire inside as well. And then you got a variable density. Okay. Regardless, let's just start getting little m. So integral of 1 dv. This is how you're going to find your volume. Oh, wait. But we have a variable density. So normally we just put a 1 for just finding the volume. But because we have a variable density, I'm going to put this guy in and then dv. Okay. All right, so now let's go and find it. Let's set this thing up. 7y dz dy dx. Now, this is where it kind of gets a little interesting. I like to call this dimensional reduction. It's just my personal name for it. I'm sure it's called something else. But let's go back to my plane for just a second here. I want to move all these guys over. So z equals 2 minus x squared minus... z equals 2 minus x minus y. Cool. So I like that. But what if I got rid of my z? What if I went from 3D into 2D xy, and it would be some kind of triangle region right here, yeah? Basically, I'm completing this integral here. What am I left with is still a triangle. But now, because it's on the xy plane, z goes to 0. So then I essentially have this, and let's solve for y, because that's typical. Y is going to equal 2 minus x. And again, these functions here are going to be used. That's a check mark, I'm saying. Check mark, check mark. I'm going to be using these as I keep going. Okay, what if I reduced it down to 1 dimension now, just a number line, and so I got my 0 here all the way to 2. So how do I make that work? Well, again, what I start with is x, y, z, so x, 0, 0 equals 2, and you can see x equals 2. Again, that's going to be these are my limits here. Well, they already gave you the zeros, so essentially my limits will all have zeros at the bottom. They already said that in the original problem. First octant and all that stuff. And so what I'm doing up here is for my z's, I got z is equal to 2 minus x minus y. For my y's, it's equal to 2 minus x. And then for x's, it's just 2. So notice this right here. This is why I call it dimensional reduction, because you start with this, and I say, okay, get rid of y. All right, get rid of x. Like if you had another letter, you would get rid of that, get rid of that, get rid of that, and eventually get down to a number. Okay. So let's go ahead and start taking integrals. So my z, of course, I don't have any z's. So you just plop one in, push this into 0 here. Will go away. So you're multiplying it by this guy right here, dy dx. Okay. Now, of course, now my integral is not going to be as easy. What I'm going to do is distribute. Try my hardest to make it look good here. 7 times 2 is going to be a 14. Y minus 7xy minus 7y squared dy dx. Okay, so now we're going to integrate for my y's now. So here, divide by 2 would make a 7y squared. Here we get 7 halves xy squared. and we get a cube here, so 7/3 y cubed. From 0 to this 2 minus x. Of course, everywhere there's a y, I'm going to toss this guy in. 0 is going to cancel. So this guy is going to look really crazy. And we are only on part 1 of about 4. Not kidding you. This is just that kind of problem. Okay. Phew. You know what I did here? I did my calculator for sure. And I got 14/3. I mean, it's not a bad integral. It just takes a whole long time to FOIL it out and get the answers. I want to skip to the end with you on this recording. And again, using calculator for stuff like this is not necessarily bad. Okay. So they're going to want x bar, y bar, and z bar. So let's start with the x bar. Basically, I'm going to do this whole integral over again. 0 to 2, 0 to 2 minus x, 0 to 2 minus x minus y of now 7xy dz, dy, dx. Now, why is that? Because, again, I'm tossing that x in there, all divided by 14/3. So I'm going way back to the formulas a couple sections ago where I have my m sub, I guess this would be m sub yz or something like that, and then divide by little m to find my x. So I'm just tossing this x in there, redoing it, divide by little m. That's all we're doing there. Okay. So because we're divided by a fraction, I can flip it into the numerator, make it look a little bit better for me. Again, I don't have any z's, so go ahead and just toss this down like we did last time. If you're By the way, I'm going fast. I really am, because it's a recording and stuff like that. And there's a lot to do. So I'm not doing the little steps like that. But just let's pause for a second. I don't have a z, and so I'm basically have 7xyz from 0 to 2 minus x minus y. And I say, okay, we'll plug it into the z, and the 0 is going to cancel, and you're left with this guy. I'm doing this intermediate step real quick, because I don't really need to do it for you, I'm hoping. But you can see that it is something simple. Distribute. Again, we want to make it look pretty so that we can actually get this integral to work. So 14xy minus 7x squared y minus 7xy squared dy dx. All right, now we're going to integrate in terms of the y. So then y squared over 2 would make that a 7 in the front, y squared over 2, and then here y cubed over 3, and then from 0 to 2 minus x. Toss this into everything that's y. You can see I'm going to try to get a little bit of room here. And so 7x, 2 minus x squared minus 7 halves x squared, 2 minus x squared minus 7/3 x, 2 minus x cubed. Again, the 0 cancels, thankfully. Dx, and you know what I did at this point. I did my calculator. I mean, it takes a while to type it in, but I mean, would you rather do your calculator, or would you rather do that stuff by hand? And I'd say calculator. So with the 3/14 in the front, you actually end up with 2/5, and this again is my x bar. I am going to just tell you to repeat for y bar and z bar, but I'm going to give you the answers right quick because, well, there you go. But honestly, as far as lecturing is concerned, there is nothing new here. So we got 4/5 and 2/5 again. There's nothing really new to this. It's just doing more, okay? So using the same skills, just doing more of them. Thank you very much. Have a great day.